Hello everyone. So this is the experiment for constant velocity and constant accelerated motion. So we have an air track and the cart is going to be gliding along this one-dimensional air track. And the reason for the air track is to reduce friction. So we can consider friction to be basically negligible in this particular experiment. Okay? So the first part of the lab, I have the cart with different flag lengths. So this right here, the default flag right here is a 10 centimeter flag length. And then I can attach these cardboard flags to increase the flag length. And basically what's going to happen is I'm going to launch the cart, and at the beginning it's on a nice horizontal air track, so a flat air track. And the timer here will record the time it takes, in this case the 15 centimeter flag, to pass through the photo gate. Okay, so I'm getting the time it takes that flag length to pass through the photo gate. So you can think of the flag length as being the displacement. So if I know the displacement, and I know the time it takes for the cart to undergo that displacement, then I can calculate the velocity of the cart. And the goal for the first part of the experiment is to basically achieve a constant velocity of the cart, okay, over all the different conditions, over the 5 different flag lengths. So to do that, we're going to hold this back on the rubber band launcher, right? So some consistent amount each time. Release it, and then basically I'm going to record that time, and I'll do 5 trials for each of the flag lengths. Now, assuming that I hold this back the same amount every time and release it consistently, even if I have a longer flag length on here, then it should be moving at a constant velocity. So the flag length may be a little longer, but then the time will also increase by the same proportion. Okay? So that's the first part of the experiment, the constant velocity part. The next part deals with constant acceleration. So for that part, what we're going to do is we're going to elevate the air track. So I'm going to put one side up on this little weight here, so it's at an incline. And now, we're going to start the cart at rest, so right before it triggers the photo gate, and we're going to release it, and it's going to accelerate down the air track. And again, what we're recording is the time it takes that flag to pass through the photo gate. Okay? Now, it turns out that the acceleration is, first of all, it's constant. And it ends up being a fraction of g. Right? Remember, g is around 9.8 meters per second squared, or 980 centimeters per second squared if we're using CGS units. So the acceleration of this cart on the air track when it's inclined like this tends to be a fraction of g. And the way that we figure that out is we measure, and I'll do this for you guys, I'll give you all this data. We measure the height of one end of the air track, and then the height of the other end of the air track. So we know the total length of the air track. It turns out it's 2 meters, or 200 centimeters. Therefore, we can figure out the angle theta that the air track makes with the lab bench, with the horizontal. And that will give us the acceleration. The acceleration, you can work this out, it ends up being g, 9.8, or 980, times the sine of theta. Okay? So we will actually figure out the acceleration using that method, so using the geometry, and also we'll figure it out based on our data that we get. Okay, so that's it. That's the experiment for constant velocity, constant acceleration. Thanks.